Welcome back everyone, Patrick here. Moving on to the next question. So we're told if a solid has a volume, that is that expression right there, 4 pi x cubed minus 12 pi x squared plus 9 pi x, we have to find the type of solid and its characteristics. So this question, it's a little bit unique because notice that here we're not given the kind of solid we're working with. We're not told whether it's a sphere or a cylinder or whatever, and we're not told what characteristics we have to find. So before, usually we were given area expressions. We have to find the length and width of a rectangle, for example, or we were given volume expressions and we were told the solid and the characteristics like radius and height to find, for example. But in this case, we sort of have to just work with this abstract volume expression and figure out what we're working with. So as usual, what we can do is we can take this expression, we can factor it, as we usually do with these types of questions, and then from there we can maybe see the type of format that the volume is in, and then we can see, does it relate to one of the volume formulas that we are familiar with. So let's try to factor it first and see what we get. So notice that between all these expressions, they contain a pi, so we could definitely take out a pi. Between the 4, 12, and 9, there's no common factor there, but also notice that each of these contain an x, and the lowest exponent is x to the power 1. So out of all of these, we could take out a pi x, and what would we be left with in the bracket there? Well, we would just divide each of these expressions by that greatest common factor that we took out, pi x. So in this case, we'd have 4. The pi's cancel out, x to the 3 over x to the 1 gives us x squared. Minus, the negative comes down, the pi's cancel out, x squared over x is x to the 1, we got the 12 still, and then we have the plus, and then the pi's cancel out, the x's cancel out, so we're just left with a 9, like that. And then further, let's see if we can factor this bracket right here. So notice that it is a quadratic. And so let's see if we could factor with decomposition. So notice that the A value is 4, the B value is negative 12, the C value is 9. The AC value is 36, right? 4 times 9. So we've got to find two numbers that multiply to that AC value of 36, add up to that B value of negative 12. And the two numbers would be negative 6 and negative 6. Like that, right? Negative 6 times negative 6 gives us positive 36. Negative 6 plus negative 6 gives us negative 12. So then we decompose that B value like that, right? And so from here, we can factor by grouping from these two. We could take out a 2x, so we'd be left with 2x minus 3. And then from these two, notice there's a negative here, so we're definitely going to take out a negative value between 6 and 9. We could take out a 3, and we'd be left with 2x minus 3 again. Then we could take out that bracket, and then notice we're left with a 2x minus 3. So notice in this case, it's a perfect square trinomial. 2x minus 3 times 2x minus 3, which is like 2x minus 3. Squared. So this bracket factors into that. So we end up with pi x 2x minus 3 squared, like that. And if you look at this over here, what is a volume expression that would be in this kind of format? Well, notice it's going to be the volume of a cylinder. We know the volume of a cylinder is what? Pi r squared h, like that. So we can actually take this, or actually, you know what? Let's take the formula instead, rewrite it. Notice that in this case, we have r squared over here and then the h over here. So we could actually flip those. Because we're multiplying, doesn't matter which order we're going in. Usually it's like this, but we can switch it up in order for it to be in that same format right there, right? And so notice that we're dealing with a cylinder in this case, okay? It wouldn't be, for example, like a sphere, because we know a sphere, that's the volume formula for a sphere. And notice that this it's not the same as this, right? There's no like factor to the power of 3. There's no 4/3 in front. The solid that we're dealing with in this case is a cylinder. Okay, so again, kind of a weird question where you first have to factor everything and then look at the type of formula that you're dealing with. But once you write out some of the maybe volume formulas on the side, you'd notice that you're dealing with a cylinder over here. And so notice that we got a pi. We have an x for the h. So notice that, again, we're working with a cylinder. What are its characteristics? Well, notice that the height is going to be x units. And then notice that r to the power 2, 2x minus 3 to the power 2. So notice that the radius is going to be 2x minus 3. Right? And that ends up being the answer. So again, we're dealing with factoring. This is in the factoring section. So we had to take this, we had to factor it. So we got practice with factoring, taking out a greatest common factor, and then you can see that you're working with a cylinder. The height is x units, the radius is 2x minus 3 units.